Alright, in this video we're going to learn how to calculate slope. So here are 2 points which I'm going to roughly sketch on a coordinate plane. 2, 9, so we go over 2 spots and then up 9, and again I'm just sort of approximating the location here. And 6, 11, which would be go over 6 spots and up 11, so it's going to be a little bit above here. So again, this is not really to scale, it's just an approximation, so you can visualize this. So the slope is basically tells you, if you draw a line between these points, it tells us sort of how steep the line is. And the higher the slope, at least the higher the magnitude, the steeper it is. But anyway, the way slope is typically calculated, the way we often think of it is rise over run is one way of thinking about it. So the rise is how much between the points. If we read from left to right, it either goes up or down. So here this started at a height of 9, it goes to 11, so it has a rise of 2. And the run is how much it goes from left to right. We always lead from left to right. So this starts at 2, goes to 6, so that is a run of 4. So in this particular case, the slope is 2 over 4, or we would say it's 1/2. The symbol we usually use for slope is m. So the slope of this is 1/2, which means that for every 2 we go over, we go up 1, which is confirmed here. Another way to think of slope, this is a formula for slope, is y2 minus y1 over x2 minus x1. Now it doesn't matter actually which ones you call the second point or the first point, as long as you're consistent. So if I want to call this the second point and this the first, then y2 would be the y coordinate of that, so it would be 11 minus the y coordinate of the other one, 9, divided by the x coordinate of the second point, 6, minus the x coordinate, 2. So here we get 2 over 4, which again is 1/2. So either way you do it, you should get the same slope. Here's another one, so I'll just sketch it so we have a visual. Negative 3, 10, so if I go back about 3 and go up 10, I'm just going to make it around here actually, negative 3, 10. And the other one is negative 6, 19, so I'd have to go back even further and up even further. This would be negative 6, 19. Again, this is just for reference, because when I draw this line reading from left to right drops. This is actually going to be a negative slope. So if I want to do the rise over run on the graph, I say, okay, it drops from 19 to 10. So its rise is negative 9, because it drops 9, and it goes from negative 6 to negative 3. So its run is 3, so I get negative 9 over 3, which is negative 3 is the slope. So again, it's negative because it's moving from the top to the bottom when you read left to right, and 3 is a relatively steeper slope compared to our last one. And the other thing we can do is we can say slope is y2 minus y1 over x2 minus x1, and it doesn't matter which points we call which. So again, if I call this point 2 and this point 1, we'll have 19 minus 10 on top, and then I'll have negative 6 minus negative 3 on the bottom. So on top I'm going to get 9, and on the bottom I have negative 6 minus a negative 3, which is the same as saying negative 6 plus positive 3, which is negative 3. So again, I get negative 3 for a slope, which again we abbreviate m. So that's really all you do to calculate slope. You just need 2 points, find the difference in y between them, find the difference in x between them, and divide them. And that's it. So until next time, I am Derek Genova. Have a delightful day.